Hello everyone, this is Murali Krishna. Today I'm going to explain you about my software presentation on Hugging Face transformations. This will use NLP. Uh, yeah. So basically, what is Hugging Face transformation? Uh, it's an Python library which uses NLP and which makes people to use NLP easier. It also provides a large number of pre-trained models, and it is built on both PyTorch and TensorFlow, so people can use whatever they want to. It basically supports all kinds of things like text classification, question answering, sentiment emotion analysis, translation, and text generation, GPT, exam, etc. So, like, what are the key features? Basically, it contains, as I said before, it contains an NLP library. Using pipeline, we can access NLP very easily. In this software explanation, I'm going to explain you about how we can use pipeline and how we can do without using pipeline also. So as I said before, uh, it uses 100K plus pre-trained models. It's very easy to use and it's very easy to load models like auto model, auto tokenizer, etc. As I said earlier, it works both on PyTorch and TensorFlow. It supports tasks like classification, QA generation, and everything as before. So where can we use this? It's basically a chatbot. It's mostly useful for creating chatbot and virtual assistants. It can detect people's emotion by their face or by their text or anything else. So as like this, like it can be used for text summarization, and it can be used for translation and multilingual NLP. Like if you say a sentence in English, it will convert into France until the second language is supported by the same language. Sorry, same model, and it can generate the context. Like it can reply you back by saying what you needed from the text you have given. So from I said I'll do with pipeline without pipeline, right? So like this is for with the pipeline. So oh, yeah, and as I said earlier, it can be used in both PyTorch and TensorFlow, and it can be used locally or you can use in Google Colab or Jupyter Notebook. It is compatible with both CPU and GPU. So for the requirements and all, we don't need any API key to log into this sorry, to use this API. And just Python 3.6 or higher can support this. So this is the Python API. So here I'm going to explain you a little bit about how I install it. So you can see here, I have imported pipeline from the transformers, which is a inbuilt model which supports pipeline. And I have given the pipeline, I have taken the BERT uh, emotion detection classifier, and I have given it to the classifier, as you can see here. And I have checked whether the device is set to CPU or GPU to just to show you it can be used by both. GPU obviously can raise it. You can use any model, but we can use this with CPU also until it meets the requirement. So I'm going to just write a text like I feel amazing today, like shockingly. So it will just give the result of emotion. You can see here surprise, and you can see the confidence score, like how much confidence it is saying it's surprise. So 0.76 is a very good number to say whether the sentence is saying he is surprised or not. So yeah. And the second part of this is, as we saw earlier, it just gave in two, three sentences using pipeline. In two, three code sentences, we can just the text emotion by text. So I'm going to build a manual model also to just let you know how we can build a manual model and how important it is to use this method rather than building a manual model. But there are some limitations in using pipeline also. It's not ideal for advanced logic or scaling and abstracts away what's really happening, and it's very hard to uh, get back also. And what manual controlling helps us is like to study how pipeline works and to get back if there is any issues with the pipeline. It gives us the flexibility where we can change whatever we want inside the model. But I guess for beginners, it's not a big necessity to change the manual controlling and all. But I am just going to show how manual controlling works. So I'm going to load the model manually. I'll show you here. See, as before, like I have imported like directly pipeline from the transformers, but now I am going to import you the model and the tokenizer. The tokenizer is auto tokenizer from the transformers, and the model is like auto model for sequence classification. And you can see the model I have selected is the BERT, and I have imported the model. And this is the tokenization step where I'm going to show you how we can tokenize the sentence I have given. So like you can see here, if the sentence is given as this is a tokenization, it will then split the sentence into this is tokenization. So it will just study the words whether this is what is, what is token, what is origination. It will study it by converting into token IDs, which will then be imported into the word function, which I showed you before. So like basically this step advantage is like we can see how the sentence person gave and how it is converted into it. So if you think the token got wrong code, then you can verify it and you can change it. But most of the cases it will be correct code only. But if you want to change anything inside, so you can do it like because if a sentence has is 10 times and it might detect all is's are same, right? So we can see that. So this is what I'm saying about the text is I don't feel good about this. So the input takes the TensorFlow, sorry, the tensor, and it will just create the sentence into tokens. So you can see the tensor tokens for the each letter for I and for don't, for feel, for about, and for this. So then we'll copy them into inputs, and this is my next step, which we are going to interface with the raw model. Like we have taken the inputs, right? So we're going to convert them into logits, which are recognized by the model. So I'm using softmax to convert them into probabilities, and the class with the highest score is our predicted emotion. So yeah, and you can see here I have imported torch and torch function. So I'm going to give the inputs I have got here. I mean like the tokenized IDs, and I am converting them into logits here. So like using the logits function or outputs.logits function. And I am going to give it to the tensor and then functional SF. And using the softmax function, I am going to find which logit has most probability and to get which has more. So like you can see this is that I don't feel good about this, right? So 6 words, right? You can see the 6 ones, 1, 2, 3, 4, 5, 6, 7, 4. So for I, which has more, and for this, which has more, for feel, which has more, good, which has more, about, which has more, and this, which has more. So it will then recognize the sentence in a way the system recognizes by using the probability and using the softmax function. So yeah. And this is the custom emotion detection function, which like detects the word like the probabilities, which will detect the emotion from it. So basically, uh, it will just accept the text as input and tokenize the text and pass it through the model and apply softmax to grade probabilities and return the predicted label and confidence interval. So like the 5, 6 steps we did till now, it will just combine them and it will wrap into a function so that you could just use this function rather than using all the steps. It is also a built-in step for pipeline, as you can know that pipeline does in very less way. So like it is very reusable. It can wrap all things in one, and we can use this logic continuously by using a for loop or something like that. So we can just keep our code clean also. So you can see that function here. It is converting the text into tokenizers. and it is giving the inputs to logits, and it is then using softmax to get the logits, and it is then predicting which has more probability. So like I'm just running this function, and you can see, right, the text I feel amazing today, and see the confidence interval, the same we got before, like surprise and 0.76 using the pipeline here. So like I'm going to change a new sentence just to know whether it works for everything or not. So like you can see, why does everything go wrong for me? It gives anger and confidence of 0.73. So like we can even try for like the before text which I have given. So if I run this, I'm getting, I don't feel good about this as joy and confidence one. So there might be error in this because the data may be wrong. But anyway, yeah, I just showed you whether it works or not. So going to the next step, it is batch processing. In this, I'm gonna give like bunch of text to a function, and I'm gonna run the before function, this emotion detect function with the batch processing, which will help us run all the texts at the same time. So you can see the batch. I have given the batch here, and I have taken the batch into a batch like this. I have converted all of them into that. And you can see I'm just running all the texts at once. So like you see, I'm feeling really low today means it gives sadness and with confidence one. This is such an exciting moment. It gives joy and confidence one. Everything is falling apart, sadness and confidence one. I love how this day is going, joy and confidence one. I'm just tired of all of this. Like it gives sadness and confidence one. So like we can work through bunch of statements at the same time using this batch and emotion detection function. This is what the pipeline did in the starting. So yeah. So to just say about this, like instead of processing messages one by one, we can just use batch processing. It is more efficient, and especially if we are working with a large input, as we are working on our uh, music recommendation chatbot. These functions are very usable for that. So I have taken this, and this is just to let you know how we will integrate the emotion to the song. So I'm gonna give a uh, emotions and playlist for a general use case. So you can see if it is joy, upbeat pop, sadness, mellow vibes, anger, heavy rock, fear, calming instruments, love, romantic mix, surprise, high tracks, like that. So I'm just gonna attach this list to the function I have given before, so that it will directly take the function, and it will connect it with this, and it will take the emotion from it, and it will detect the what kind of songs they might like. So you can see here, I'm going to run this message, which is like message, and it will detect the emotion, the top part, and this is the second part, just joining the both of them. So I feel amazing today. As we saw, it's joy. So it is giving the hype tracks. And let's go through the second sentence. I feel like everything is falling apart. It is sadness. So let's see what it will give. So it is sadness, and it gave mellow vibes as I given sadness as mellow vibes. So this is just what we are going to do for our final project as well. So yeah, this is the real use case. And these is about the strengths and trends of the Hugging Face transformations. Uh, If you pass a chat message to the classifier, it returns the emotion label and confidences. You can use that label to recommend a music playlist, and this simulates what happens inside your actual chatbot project. So, like, we have two data sets, right? Go Emotion and the other one is like Spotify. So our Go Emotion, it needs the Hugging Face transformation, which will detect all the sentences we have passed to the emotion. So our Spotify data from our Spotify dataset, we're going to attach the emotion to a right uh, song playlist using the valence and all. So in this case, I am considering the confidence as the valence value. So I'm going to attach the confidence to a particular valence and get the song out of it. So yeah, you can see here the cross framework support is compatible with the PyTorch, TensorFlow, and JAX. Look, so like I can use it in my local system, and also we can use it in the collab also. So coming to the limitations of the Hugging Face. The large models can be memory heavy and GPU may be required for real-time systems. When I ran the first code snippet, I have shown you that I have worked on CPU for this software explanation because I am just using like 10 to 11 sentences, not more than that. So if you want to use like, thousands of sentences or more than that, we surely need GPU or else this is gonna take too much time. Anyway, whoever worked on LLP already knew that we need large base systems to run NLP codes. But yeah, this Hugging Face transformation takes even more because we are going to get an emotion out of the sentence, or we are going to reply to a chat rather than just explaining what the chat is. So we are going to do the double work. So we need even more bigger GPU systems. So this is the biggest limitation for Hugging Face transformation because we need large amount of GPU to run it through any model. So we can't use it locally wherever we want unless it met with our requirements of small size data. So like obviously like you need to download it or you can't get it. So that is another limitation. So summary finally. As we said in the first slide itself, I have shown you. Now I guess every one of you will also uh, just say that yeah, Hugging Face transformation is a powerful NLP library. So yeah, that is my most important thing I want to say. And you can also say that, using pipelines is a lot better than, doing it manually. But if you want to be a professional and if you want to correct mistakes, or if you want to find mistakes, like, see, you can see here, right? The sentence, I don't feel good about this means it is giving joy. So this is a major error. So, for sentences like this, if you want to see why it is going wrong, we obviously need to know how manually it works. So we have learned using how it is going to work using pipeline, and we have learned how we are going to use using manually. Just we need custom functions like the function which needs to detect the emotion from the sentence and batch processing, which is going to wrap this up. So yeah. So I have also demonstrated how integrates with the real project using our project example by creating this emotion playlist. But for this, you need to keep the balance exactly to the confidence interval to get correct setting. For example, if the sentence is joyful, if we give little less valence, then it won't be giving any joy kind of song. So we need to be very cautious about that. And one more thing is like, y- yeah, that's it. Thanks for watching this video. I hope I explained you, and I hope you know what Hugging Face after listening to me. So thanks for the opportunity. And thank you.